Hello everyone, my name is Mohan, and in this video we're going to solve the third problem from the top interview 150 questions from the LeetCode. And the problem is removing duplicates from the sorted array, which is very similar to the previous problem that we solved, which is removing the given element from the sorted array. But here in this problem we are going to remove the duplicates from the sorted array. And here is the problem statement: is given an array integer nums sorted in non-decreasing order, and we need to remove the duplicates in place. Right, as we solved in the previous problem, in place is like manipulating the current array in such a way that we will get the current array with deserved output, right? So that's where we need to solve the problem, and such that each unique element appears only once, right? And the relative order of the element should be kept the same. So here we need to preserve the order. In the previous problem that we solved, there is no need to preserve any order. But in this problem that we are solving, we need to preserve the order, and we need to consider the number of unique elements in the array to be k. After removing the duplicates, we need to return the number of unique elements k, right? And the first k elements of the nums should contain the unique numbers in the sorted array, and the remaining elements can be ignored, right? So let's look into the example here, and let's look into second example. You can see that the nums 0 1, the array of the nums that was given 0 0 1 1 1 with the duplicates in it, and we need to remove the duplicates. For example, 0, you can see that in the output the duplicates have been removed, like 0 1 1 has been removed, and 2 is removed, 3 is removed. Here in the output you can see 0 1 2 3 4. That is the output, and it's in the preserved order, right? The order is been preserved. For example, in the last element we saw that in one of the approaches we did not preserve the order. The 4 we can put it in the middle, but here the last element we kept it in the front whenever we find the given element in the array. So we replaced with the last element. In that approach we did not preserve the order, but here we need to preserve it in such a way that it's the unique elements will come one after the other, right? So your function should return k equals to 5, right? So we need to return k value, which is 5. As soon as we saw this problem with this problem statement, the first approach we come into our mind is the brute force, right? So we will try to go to all the elements in the nums. We will compare the current element with the next consecutive element, and we will check if they are duplicates or not. If they are duplicates, then we will remove the current element, right? So that's what we will get into our mind, and we will but the problem is that we will try to remove the element. Whenever we'll try to remove the element, it's very expensive. As we saw in the previous problem, the inbuilt remove function is very expensive, because it will go through the entire array. It will try to find the first occurrence of the whatever the element we want to remove, and it will remove that element, and then it will move the next elements to one step front, right? That's how inbuilt remove function works. That's why it's very expensive. So we're gonna optimize the brute force approach, and see whether without removing it we can try to remove the duplicates by preserving the order, right? So that's how we're gonna do. And here what we're gonna do is we're gonna try to implement brute force first, right? We're gonna implement brute force with tracking the element of the length, because whenever we try to remove the element, the length of the array will be reduced, right? If we go through the entire array, for example, while I is less than k, and if nums of I, right, nums of I equal to nums of I plus 1, right? For current element we are comparing current element with the next consecutive element, and we are checking if they are equal or not. Then if they are equal, then we are remove that element from the nums, right? And then if we are removing, the length of the nums will be reduced to 1. So what we're going to do is we're going to reduce that k value to 1, and then or else or else then we're gonna increase the I value to 1, because in here we should not increase the value of I to 1, because here if we are removing the current element, right, we are removing the current element, then this 0 will come to this index and 1 will come to the index 1, right? If we increase it, the I value will become 1 here, then this value will be ignored for checking with the future elements. For example, if we are in on this index and we are checking this one with this one and we know that it's a duplicate, then we will drop this, like we will remove that 1 from the array, and this one will come to the index 2 and this one will come to the index 3. Then if we move I here, then the I value will be on index 3 and it will check index 3 with index 4 instead of checking index 2 with index 3, because index 2 and index 3 are duplicates here. So that's where we're gonna keep the I value at the same index whenever we encounter the duplicate, right? So that's how we're gonna solve it here, and then we're gonna return the k value, right? So we're gonna return the k value and we're gonna run and see. Okay, out of range. Okay, oh right, I is less than k minus 1, right? Yeah, because we are checking with until I plus 1, so the length of the, we need to check one element before the length of the array. So I think it should work now. Yeah, it's executed. So let's submit this and see if it's submitted. Right, you can see that we're just beating, we are in this position here at the end of the all the people in front of us, right? We are just beating 5% of the people, right? So we need to change the approach here. We need to get more optimized approach, right? So it's the same pattern. We're going to use the same pattern for this optimized approach as well. In the previous element, what we did, we find the given value, whatever the given value here, and we tried in that approach, we gonna, if the two elements are not equal, like if the given element is not equals to the value, then what we did is we're gonna replace that current element with the previous non-val element, right? If we code it, then you will understand very easily with the code, right? So I'm gonna copy this because it's the same approach pretty much, but just we are using the brute force method, like instead of not brute force, just we are using, instead of removing here, we're gonna replace that nums value with the k value, right? Let me solve this. K is 0, right? Okay, let's just name it as optimize. So what we're gonna do is we're gonna go till the end of the length, right? We're gonna go through every element here from 0 to end of the length of the nums, right? So if we are nums of k is not equals to, here the k value is 0, right? K value is 0, 0th index, and we are checking nums of 0, which is 0, not equals to nums of I. If it's not equals to nums of I is also 0, right? Then we're gonna put nums of I with nums of k, or right, nums of k with nums of I, right? And then what we're going to do is we're going to increase the value of I, and yeah, pretty much that's all. And or else if it's equal to, for example, if it's duplicate, right? Let's just check from 1 to 3. Right, the k value is here, k value is in the index 2 and the I value is in the index 3. What we will do is we will check the k value and we will check the I value and we will compare if they are not equal to or not. They are equal to, so we're gonna keep it like this. K will be at the index 1 only, right? But I moves to index 3. right? Again it will check here, and they are not equal to, they're like equal to, right? So then the k still stands here, and the I moves to 2 here, and then it will check again, then k value will be replaced with the 2 here. It is equal to, so k value will be replaced with the 2 here, and then because I will be replaced with the 1 here already, so k value will be replaced with 2 here, and then k will be move on to the next element, which is the third index. So pretty much that's how it will work. I hope you understand clearly. Let me uh, I all right, so I hope you understand clearly what I'm saying here. It's just that we gonna replace the k value, the previous duplicate element, with the current non-duplicate element, right? It's the same approach that we took in the previous problem, and we're just replacing that with the non-duplicate element instead of replacing with the other element like before, right? So, and the reason here we are doing is because the time complexity it's going to take is only, it's going to run through one time in the entire array, and it's going to be O of n times, right? That's why we are trying to do with this approach, and it should work. Let's run and see. Let's okay, I think it's the reason is we are checking from the first element, but we need to we are checking the first element of the array of index 0. So let's run and see. I think it should work because we are checking from the second element. Okay, okay, nums of k, we are checking nums of k not equals to nums of k, or maybe nums of I, current element, which is not equals to nums of k, right? And then which is not equals to nums of k, then nums of k should be replaced with nums of I, right? Then nums of, I think if it's not equal, let's see. If one, for example, let's just start from the beginning. Nums is 0, right? Nums of I is 0, and it's k is also, I is 1, k is also 1, and it will check with the k with the I. Oh, right, we're gonna check with the previous element, right? All right, so we're gonna check with the previous element of the k, and it should if we are checking the previous element of the k, and if at this beginning, right, we're gonna see if it's a duplicate or not. Then if it's duplicate, then nums of k minus 1, it should be k minus 1. All right, so we're checking with this element, right? 0 with 0, then nums of k, nums of 0 will be replaced with the nums of I not equal to, right? Here 0 equal to, if it's, all right, so that's right. Here this both are equals to 0, so it's not going to do anything. Then the I value will be moved to next element, right? I will be 2, right, and the k will be 1 here, and it's gonna check it, the both are not equal to, they're not equal to each other. So what it's gonna do is it's gonna replace k with 1. So here the first index 1 will replace with the value of 1, and the k value will be moved to here the index 1. So k value will be index 1, and the I value will be, obviously it keeps on moving. So that's pretty much should solve the issue. So if we run it, there you go, it's working. It's just that we are replacing the current non-duplicate duplicate element with the non-duplicate element, right? We are tracking the duplicate element with k, and we are tracking the non-duplicate element with I. We are just replacing the duplicate element with non-duplicate element, and we are, whenever we are replacing it, we are just moving the index of duplicate element to 1, and the non-duplicate element we are keep on rotating from the until the end of the array. So that's how we are solving it, and let's submit and see if it's optimized or not. It's almost optimized, 56%. Maybe we can submit one more time. Sometimes, I mean, it's it's pretty much optimized. Pretty much it's similar to, oh, right. Yeah, pretty much it's the more optimized solution here, and it should give the optimized approach. It's yeah, so I hope you learn something from it. I hope you understand the approach that we took to solve this in an optimized approach.